Welcome back. This is Mr. Hassan's Maths channel, and I am answering question number 4 from the International A-Level Edexcel Pure Mathematics P3 June/October 2020 examination paper. And this question here is about the absolute value of functions from the chapter on graphs and functions. Now, it says figure 2 shows a sketch of part of the graph with the equation y equals f of x, where f of x equals 21 minus 2 times the modulus of 2 minus x, and x is greater than or equal to 0. As we see, the graph starts from the y-axis, where x is equal to 0. It doesn't go below that or beyond that on the negative side. It says find f of f6. Well, basically what all this means is they want you to find what f of 6 is, substitute 6 inside the function f, and then what comes out of that, put it back into the function f again. So basically what it means is this. It means f6. Substitute 6 into function f, and then the result into function f again, basically. So first of all, let's find out what f6 is. So let's find out what f6 is. f6 is when you replace 6 the x with the 6 inside this function. So you have 21 minus 2 times the modulus of 2 minus, instead of x, I'm going to write 6. This is going to give me 21 minus 2 times the modulus of negative 4. Okay, now, the modulus of negative 4 is equal to 4. Okay, the modulus or absolute value means, one way you can understand it is its distance from 0 on the number line. So the distance of negative 4 from 0 on the number line is 4 units. So you just care about how far it is from 0 without considering its direction, just the magnitude. Okay, so similarly, the number 4 would also have a magnitude or absolute value of 4 as well. It's not just that you change the sign. If it's positive, it stays as positive. The magnitude of 4, or the absolute value of 4, is 4. The absolute value of negative 4 is also 4. So this negative 4 inside this is going to be replaced with a 4, and I'll change the modular sign now into a bracket. So this is going to give you 21 minus 8, which is 13. And then we've got to replace inside function f again. This time we've got to replace it with 13, because that's, so we're going to find f of 13. 13 is equal to f6. f6 equals 13, so if you replace 13 inside the function f, it's like you've put f6 inside the function f. So that's going to give you 21 minus 2 times 2 minus, instead of x, you're going to put 13, which is going to give you 21 minus 2 times 2 minus 13 is minus 11. So it's a modulus, still the modulus, not bracket. It's a modulus of negative 11, which, and as we can see from here, the modulus of negative 11 will give you 11. So you're going to have 21 minus 2 times 11, okay, which is 21 minus 22, which is minus 1. So we can see that f of 6 is equal to negative 1, and that's the answer to part A of this question. Okay, so that's the answer to part A. Just simple arithmetic kind of thing here with the modulus sign. Now part B, it says solve the equation f of x equals 5x. So I've just got a copy of the diagram here, and this is the equation that we are going to, this is the equation of the graph given, and we've got to solve the equation f of x equals 5x. Now there's different ways of solving such an equation. Some people do a purely algebraic approach, and they don't actually think about the answers, and they get like some answers, and some of those answers might not actually be correct answers. It might give you an algebraic approach might give you certain answers which are not actually answers which satisfy this. So there's two ways of doing this. As I said, algebraically, if you do it algebraically purely, then you must check to see if your answers actually satisfy the equation. If you do it in a way which is if you do this in a way which is like graphically, then you can solve it quite easily without having to go through that process of having to check, because you can see your solution. So I'm going to show you the graphic way. I personally prefer how to do this in the graphic way. So I'll show you that way first, and then I'll show you the algebraic approach, and I'll show you how the algebraic approach sometimes leads to answers which aren't really true answers. And if you wrote the answer down, which is not a true answer, you will lose marks. So first of all, the algebraic, the graphic approach, what I do is I look for the positive argument of this function. The positive argument is when you keep it as it is. So I'll write this as y equals 21 minus 2 times, and I just write 2 minus x as it is, just change the modulus to a bracket. So you're going to have 21 minus 4 plus 2x. Okay, 21 minus 4 plus 2x. So y is going to be 2x plus 17. So I can see very clearly that this little section here is the positive argument, and this is 17 here where it crosses the y-axis. So this part is y equals 2x plus 17 because it has a positive gradient. And the other argument, the negative argument of the graph, is going to be, of course, this other branch here, and that's when you basically change this into like you change the modulus sign. You change what's inside here, change the sign of everything inside the modulus sign. You don't change the sign of the whole side, just whatever's inside the modulus. So you have 21 minus 2 times, and in brackets I'm going to put, instead of 2 minus x, I'm going to put minus 2 plus x. Just change the sign of whatever's inside the modulus. That's going to give you y equals 21. You're going to have minus 2 times minus 2, which is plus 4, and minus 2 times 2x, which is minus 2x. Okay, so that's going to give you y equals minus 2x plus 25. So this is the argument on this side. This is the graph on this side, the negative argument of the graph. Y equals minus 2x plus 25. As you can see, it's got a negative gradient. Okay, so that's the positive and negative arguments of this graph. Now we have to solve the equation where f of x equals 5x. Okay, f of x equals 5x. So if we draw the line y equals 5x, well, that's going to be a straight line which passes through the origin and has a gradient of 5. Now this has a gradient of 2. So it's going to be a steeper gradient than this, a considerably steeper gradient than this. So I'm going to draw a line which is quite steep. Okay, and this is going to be the line y equals 5x. Okay, this is y equals 5x. Okay, so we can see that they're going to intersect in one place and one place alone. Okay, and I can see that the intersection is going to be when y equals 5x and y equals minus 2x plus 5. Okay, so if I equate 5x to minus 2x plus 25, then I can find the solution. If I add 2x to both sides, I'm going to get 7x equals 25. So x equals 25 over 7. They're only asking for the solution of that equation, so they only want the x value. Okay, so that's the answer to that question, and I've got the answer, and that's the only answer. Okay, and I can see that, you know, from the graph, that there's no other place they're going to intersect. Okay, even if this graph continued on this way, it would never, they would get further apart because this has a shallower gradient than this, so this is going to drop further, faster than that. They'll never meet again. Okay, and this graph stops here, it doesn't continue, so there's no other intersection except for this, and I know that's for sure my only answer. Now, if I was to tackle this algebraically, okay, if you were to tackle this algebraically, now some students would do this algebraically. So here I just got my answer. There's no need for me to check anything because I can see from the graph that it's perfectly fine, and this is my only answer, and there I've got my solution and I'm done. Now some students would do this algebraically, and they'll say, okay, let's see where it intersects with y equals 5x. So they'll say, okay, let's make 5x equal to 21 minus 2 times the modulus of 2 minus x. Okay, so they'll take this first as in this sense here, and they'll say, okay, that's 5x equals 21 minus 2 plus 2 minus 4, plus 2x, and then they'll say, okay, that means 3x is equal to 17, so x is equal to 17 over 3. And they'll say the other argument is when 5x is equal to 21 minus 2 times minus 2 plus x. So you'll have, it's kind of similar in a way what they're doing, but they're not looking at the actual graph. So that's got plus 4 and minus 2x. So we get 5x is equal to 25 minus 2x. So you're going to get 7x is equal to 25. So x equals 25 over 7, which is the answer that we got. Now there's a question, there's an answer here, okay, which if you're not careful and you write it down, you're going to lose a mark, okay, because that answer actually is not an answer, because that's basically what you found here is where this graph meets y equals 2x plus 17. Now y equals 2x plus 17, okay, if it wasn't for the modulus, it would have continued on like this, and they would have intersected in a particular place. But you can see that this graph doesn't go as far. It goes as far as this point here. So this point is actually an extra solution. It's not a solution that we write down. It's not a solution to this particular equation with the modulus function. So that's why you have to reject it. Now, if you didn't think about it graphically, then you'd have to think about it algebraically. So what you'd have to do is you have to say, okay, let's see if it satisfies our original equation, which is 5x equals 21 minus 2 times the modulus of 2 minus x. And we said we're going to check x equals 17 over 3 and see if it satisfies this. You're going to have 5 times 17 over 3 equals 21 minus 2 times the modulus of 2 minus 17 over 3. So that's going to give you 50 plus 35, 85 over 3 equals 21 minus 2 times, you're going to have the modulus of, this is 6 over 3 minus 17 over 3, which is minus 11 over 3. Okay, so what does that give us? That gives us 85 over 3. On this side, this is 21 minus, now this is going to be 2 times 11 over 3, remember, because of the modulus sign. That becomes positive. So you have 85 over 3 equals, now 21 over 3, 21 over 1 is going to be 63 over 3 minus 22 over 3. Okay, and that gives us 41 over 3. So on this side you have 85 over 3. On this side you have 41 over 3. And of course, that's a contradiction. They're not the same. So x equals 17 over 3 is not a solution. Okay, this is not a solution. And if we were to test 25 over 7, we have 5 times 25 over 7 equals 21 minus 2 times the modulus of 2 minus 25 over 7. So let's see what this gives us. That gives us 125 over 7 equals 21 minus 2 times the modulus of, this is like 14 over 7, multiply both by 7, minus 25 over 7. Okay, so you have 125 over 7 equals, this is going to be something over 7, that's 147 over 7, right? 147 over 7 minus 2 times the modulus of, now 14 minus 25 is going to be 11, so that's negative 11 over 7. Okay, so you have 125 over 7 equals 147 over 7 minus 2 times 11 over 7. So you have 125 over 7 equals 147 over 7 minus 22 over 7. And 147 minus 22 is 125. So we get the answer 125 over 7, running out of space here, is equal to 125 over 7. So we can see that x equals 25 over 7 is a solution which satisfies the modulus equation. So we can see very clearly that 17 over 3 did not satisfy our equation and 25 over 7 did. So 25 over 7 is our solution, and 17 over 3, although it gives an algebraic answer, is not a solution to this, because it's basically finding a solution that doesn't exist, where this line continues on and hits y equals 5x, which actually doesn't actually happen in reality. That's why it doesn't solve the modulus equation. So personally, I think by looking at it graphically, it's far easier to solve such a question. Okay, and that's something important. Now, one of the students that I was marking his work when I set this paper did something which was incorrect. He said, let 21 minus 2 times 2 minus x in modulus equals 5x and then equals minus 5x. Now that only works if the whole of this side is inside a modulus. Then you can make the other side positive and negative. It's the same thing as making this side positive or negative. But if it's a modulus sign in part of the equation, then you can't do that unless you isolate the modulus sign by for example, taking away 21, or bringing the 5x onto this side. So the modular sign is on its own. So you can't just make 5x positive and then 5x negative and equate it to this to get the solutions. That won't work if the modular sign is just over a part of the expression. So it's far easier to just think about the sketch of the graph. So you find the positive argument, which we found was this part, the negative argument, which is that part, and see physically where it's going to cross, how it's going to meet the graph y equals 5x by doing a little sketch, and then that's the only solution where this y equals 5x hits the negative argument of this equation that we're given. Okay, so there's the answer to question 4 part B. Now for part C. Okay, it says, given that the equation f of x equals k, where k is a constant, has exactly 2 roots, state the set of possible values of k. So if it has exactly 2 roots, first of all, f of x equals k. K is a constant. That's basically a horizontal line. That's a line that's horizontal like this. And that line, we want to see where that line will give exactly 2 roots. Now, one of those places, if you draw a line horizontal here, it's going to give only 1 root. Okay, because this line doesn't continue on here. Okay, it would give 2 roots if the line continued on. But there's only 1 root, there's only 1 root. The point where it starts giving 2 roots is this point over here. Okay, where this point is over here, that's where it hits the y-axis. Now, we learned that this part of the graph was y equals 2x plus 17. So that's going to be, when y equals 17. So k equals 17 is the starting point. But it's going to continue having 2 roots until it reaches this point over here. Okay, then it's going to have, at this point it's going to have 1 root. But everything below this value here is going to have 2 roots. So we've got to find that point there. Okay, we've got to find that point there. Now that point there is the vertex of this graph. And the vertex of this graph is 21. Okay, because 21, y equals 21 minus 2 times 2 minus x. The highest this can ever be is 21. Okay, the highest this can ever reach is 21, because whatever value you've got here is going to be something positive, because you take the modulus of it. So whatever value x you put in here, this thing is going to be positive. So you're always going to be taking away something from 21. When this becomes 0, then you'll have 2 times 0. So this becomes, when x is 2, basically, this thing becomes 0. Okay, that's why this is x equals 2. This is probably x equals 2 here. And this is going to be 21. When x equals 2, this thing becomes 0. You have 21 minus 0, which is 21. So that's the highest it can ever reach, which is 21. So this point here is definitely 21. Okay, alternatively, you could have taken the negative argument, which is y equals minus 2x plus 25, and find out where it hits the graph y equals 2x plus 17, and it would tell you the x value as 2, and you can then find the y value. But that's a bit of a long way, but no problem. We can see 25 minus 17 is 8, and 2x plus 2x is 4, so we have x equals 2. As I said, x equals 2, I know it's this value, and what makes this 0? But when you put 2 into even this original equation or any of these 2 equations, where you'll find that you're going to get y is equal to 21. If I put 2 in here, you're going to have minus 4 plus 25, which is 21. If I put 2 in here, I'll have 4 plus 17 is 21. If I put 2 in here, I'm going to have 21 minus 0, which is 21. So y equals 21 is the y coordinate of the vertex. So we can see that it's going to have 2 solutions from when you've got y equals 17 up till 21, but just below it. At 21 itself, there's only 1 solution, because that's where it turns. But everything below 21 up to and including 17 is going to have 2 solutions. So the solutions are going to be when k is between 17, which is included, up to but not including 21, and those will give you your solutions. Okay, so you can see from the graph the y value of the vertex by just looking at it, this number on its own outside. That's the y value of the vertex. So you could do that just by looking at it, or you could find it by finding where these 2 intersect. But it's much easier to look at the graph to understand it that way. So that's the value, those are the range of values of k for which there's exactly 2 roots. And then it says part D, it says the graph with the equation y equals f of x is transformed onto the graph with y with the equation y equals a f x minus b. The vertex of the graph with the equation y equals a f x minus b is 6, 3. So this vertex here, as we said, we just worked out now, is 2 and 21. Okay, so the vertex was 2, 21, and now the vertex has become 6, 3. It's gone from here to here. This is transformed onto that. Okay, so this is the original function, and this is the new function, which is y equals a f x minus b. Now, what we got to see here, to find the values of a and b, okay, what we can see that the a value is outside the function. It's like a f of x. So this represents a vertical transformation, a vertical stretch, in fact, okay, of factor a, the vertical stretch of factor a, and it affects only the y coordinates, So anything that's outside the function, so multiplying the whole function, is affecting just the y coordinates. So we can see here that the y coordinate went from 21 to 3. Okay, and they went from 21 to 3. So the y coordinate is from 21 to 3. So basically we can see that it's been divided by 7. 21 over 7 is equal to 3. That means a must be equal to 1 over 7. Because you multiply 21 by 1/7, you're going to get 3. So a is 1/7. And we can see that the other is fx minus b. Okay, so this is a horizontal translation, okay, which of this is going to be the vector minus, well, this is going to be the BA. It's going to be B0, sorry, not A, B0, because it's the opposite sign of this. Okay, and it's going to affect only the x coordinates, Okay, so we can see the x coordinate went from 2 to 6. Okay, so it's moved 4 units to the right. So that means it's going to be a horizontal translation of 4, 0. That means b is going to be equal to 4. B is equal to 4, and you can see that when it's moved from, this is 2, it's moved to 4, you can see that it's moved to the right 4 spaces, so it's going to be x minus 4. So yeah, b is going to be 4 because it has a minus b there. It says minus b. So we can say a is equal to 1 over 7 and b is equal to 4. Okay, just using the concept of graphs and transformations of graphs. So that's the end of this question. Now remember, the things that are outside the function, multiplying the whole function, affect the y coordinates. The things that are inside the function affect the x coordinates. Okay, and what's inside the function normally goes the opposite of what you think. So if it says fx minus b, that's going to be a translation of b units to the right. B units, not minus b. Okay, horizontally, it's going to be the opposite sign basically. So this is b0. So that's why, even though it's gone to the right 4 spaces and it says a minus b, that's why you're going to put b as plus 4, because you replace b with 4, you're going to have x minus 4. So this is basically y equals 1 over 7 fx minus 4. That means it moves 4 spaces to the right, which is what's happened because it went from 2 to 6. And also the y values are going to be multiplied by 1 over 7. So 21 multiplied by 1 over 7 gives us 3. So we can see we're correct. And that concludes this question number 4 from this paper. And if you want to see other questions from the same paper, you can go to this playlist, which should show up over here, which takes you to the same paper playlist. And if you want to see questions on this topic of graphs and functions and transformations from P3, you can click on this playlist that should appear here. The card on top will take you to another P3 paper that you might be interested in, and you can click on the icon here to subscribe to the channel if you wish to do so. Thank you for watching.